My name is Sam. Welcome to JavaScript, the hard parts. Thanks, Ryan. Tonight, we're going to talk about closure. Closure is a very, very difficult concept for a lot of people to understand. I have worked personally with senior engineers who have 10 plus years of experience who still don't know what closure is, or really how to explain it effectively. In short, what it allows us to do is it allows us to give our programs programmatic memory. We can build functions or programs like once or memoize. If you're not familiar with what those are, once is essentially a function that knows when it has been called more than once, and it will not execute if it isn't the first time it's called. If you think of a video game, if you think of the first time you do something in a video game and you get a bonus amount of experience, that is a once programmatic function built behind the scenes. There are a lot of JavaScript design patterns that utilize closure. Most commonly, the module pattern. If you have ever used a library, or if you have ever exported a snippet of code from one file and imported it as a module into another, you have exercised closure. You can also build iterators and maintain state in an asynchronous world. If you don't know what that means, it is all good. All you need to know is that closure allows our functions, our programs, to remember things. Even if they get lost, they hold on to the data. It persists. Persists is a really great word. I'm going to write it down. Persists. Okay. Closure. That's what we're here to talk about. Before we dive in, we're going to talk about JavaScript as a whole and the mental model that we here at Codesmith stand behind, and we're going to diagram through some code together. Let's talk about the principles of JavaScript that we all need to be on board with before we move on to understanding how closure works. There are some pillars in JavaScript that are really, really important to understand before we can dive into actually executing and talking through code. One of these things is a function. A function is code that we can define and save and that we can use at a later time to do something, to carry out an action. You'll hear me say function definition. You'll hear me say function label. And you'll hear me say this function is executing or being invoked. We'll get into more of that as we diagram through code. But functions are chunks of code that we can save somewhere in a label and execute later on to carry out a task. The thread of execution. JavaScript is a single-threaded language. That means when JavaScript is read or interpolated in the browser or whatever environment we're running it in, the code is read by our machine top to bottom, left to right, like a book or like a piece of paper if you're reading in English. Left to right, top to bottom. The thread of execution goes that way. Memory. Any Cats fans out there? Memory is, in its simplest form, a place where we store stuff. We can get more granular if we want to, but for the purposes of tonight, all you need to know is that memory is a devoted space where we can store things. Any questions about these three principles? Okay. All right. This little chunk of code, let's talk through it. We're going to examine these three principles, talking through this chunk of code. Would anyone care to be my guinea pig to technically communicate through some code? I promise I will help. Alex, amazing. Thank you so much for volunteering. Awesome. So, Alex, is this your first hard parts?
No.
Okay. Okay, so then you might have heard some of these things that I'm going to ask you about before. So in order to execute code, we have our global execution context, i.e. the space where our code will run. There are a couple other things we need to execute this code. Do any of them come to mind looking at this diagram?
Yeah, so we're going to need our global memory.
100%. We will need global memory or a space to store stuff at the global level. Great.
It's our variable environment. And on the left, we're going to need our call stack.
Yes, 100%. Our call stack. Our call stack is a data structure built into the JavaScript runtime that keeps track of something that is very important. What does it keep track of, Alex?
It keeps track of our thread of execution. And on the call stack, our thread of execution always starts with the global execution, which is always starts on the top and is always on the bottom thereafter.
100%. Thank you, Alex. Excellent. Excellently done. So yes, couple of things. Our call stack, when we're running a program, always has this frame at the bottom, which is called global, i.e. we're in the global space. Yes, it's what tells our thread of execution, or our toe. It tells our toe that it needs to be in this space. Expertly done, Alex. Thank you, thank you, thank you. Now that we have these things set up, we have our environment variable, our global memory, we have our toe in its right place, and we have a global call stack frame on our call stack. Let's talk about code. Can you talk me through what's going on in this code snippet, Alex?
Yeah, so we're going to start line by line. So first, we're going to look at keywords. So we see let, so we're going to declare a variable using let, and the label is going to be num, and it's going to be assigned a value of 3.
And where is that variable being stored? I know I'm giving
that is being stored in the global memory,
100%.
which is the whole variable environment for the whole global execution context.
Expertly done. Go on.
And then we're going to move to the next line, looking for the keyword, which is function. So we are defining a function with the label multiply by 2, and that takes one input parameter, input number. And well, we're really just storing we don't even need to go that far. We're storing the definition multiplied by 2. I'm kind of getting ahead of myself.
You're totally okay. So just to replay the expert technical communication you're giving me, we're storing multiply by 2, right? We're storing in this label multiply by 2 the function definition of multiply by 2.
Correct.
So what is the next line that our thread of execution will hop to?
Actually, I have to. So the next line is going to be looking for the keyword again, which is a constant. So we're declaring a constant variable with the label output, and we are assigning that the value, which is the evaluated outcome of running the function multiplied by 2 with the input parameter num.
Awesome. Awesome.
Which we don't yet have. So
great. So when we hit line 6, Alex, and we see that we're declaring a new constant called output and storing, just like you said, the evaluated result of multiply by 2, passing in num, what does it mean when our thread of execution, what will our thread of execution do, when it sees that there are parentheses around this num?
So the thread of execution is going to invoke that function. It's basically saying to execute it. And within the parentheses is the parameter which it's executing it using, pretty much.
Correct. Specifically, in this case, num is an argument. Num is an argument because the function is being invoked, but it's taking the place of the parameter input number on line 2. 100% correct. So now we know we're invoking a function, right? We hit line 6. We have this label output stored in global memory. And now we need to actually invoke multiply by 2, passing in num in order to get the evaluated results to know what we're storing in output.
Yes.
What happens when we invoke a function in our execution context?
So the function gets popped onto our call stack, and a couple things happen when that goes on.
Before you get much further, just a slight correction. Push on to the call
Push,
stack.
I'm sorry, yes, push on. Push on, pop off.
Keep going, you're killing it.
All right, so it gets pushed on to the call stack,
Yes.
and it brings the thread of execution from the global execution context to a local execution context, which is multiplied by 2.
Yep, 100% correct. 100% correct. So now our toe goes into this local execution context, which is the execution context for multiply by 2, passing in num. Expertly done. So now we have a local execution context, which has its own local variable environment, local memory. Talk me through what happens inside of this local execution context.
So the very, very first thing that's going to happen in the local execution context is it's going to look for variables. Yep. And the first place it's going to look is in local memory, but there is none. So the next thing it's going to do is it's going to look in the global memory. And based on the parameter, we see that num equals 3. So we can pass 3 into multiply by 2. So now that we have our num, now we can go back into the function multiply by 2, and we can see that num is equal to input number. So we are in the local memory declaring input number equal to num, which is equal to 3. I don't know if I'm going out of order, by the way. I'm sorry.
No. You're doing great. You're doing great. Keep going.
So now that we have the input number parameter, we look into the definition. So we're declaring a constant, which is result. And we're assigning it the value of input number times 2, which is 6.
Excellent.
And we are returning the results. And returning is basically handing the variable result back to the previous context, which would be, in this case, the global, or in this case, the function, which returns it back to the global context.
100% correct.
So then that's eligible for garbage collection at that point.
Yes.
So we can pop it off our call stack. And then when that happens, the return gets passed into the global memory, which gives output the value 6 in the end. And again, I'm getting ahead of myself, but
you're okay.
I hope I'm not confusing anyone.
No, you're fine. I'm going to recap everything, but keep going. There's one more thing that happens.
So next we have another constant.
One second. I'm sorry. There's one more step. So you popped the call frame off the call stack. We've returned the number 6 into the label output. Our local execution context has become eligible for garbage collection. Where does our toe go?
Oh, so the thread of execution goes back into the global execution context where it previously was. So we're back into the main code body now, essentially.
Yep. Absolutely. Expertly done. Excellent work, Alex. Yes, 100%. Okay. Take us through line 7. Let's go.
So now we are, again, always looking to the keyword. So we're declaring a variable, which is a constant with the label new output. And we are assigning it the value, which is the evaluated output of multiply by 2 with 10 passed in as the input parameter, or the argument, I'm sorry.
You're totally fine. So we hit that multiply by 2, which is followed by parentheses with an argument passed in. So we know that we're invoking that function. Correct. Once JavaScript begins invoking a function, talk me through what happens again.
We immediately look to the function body. So So the first thing that happens is we go into a local execution context.
Yep.
Once again.
There it is.
And a few things are going to happen, which is we're going to add it pop up. We're going to push it onto our call stack.
Sorry. No, you're good.
We're going to weave our thread of execution back into the local execution context that just opened. And the first thing that happens always in a new local execution context is we look for variables. So is there a local variable? And in this case, yes, there is, because we have input number is equal to 10.
I dig it. That's terrible.
Okay.
Give me 1 second. Input number is equal to 10. Yes. Okay.
So the next thing we're going to do is look to the definition of the function, and it is declaring a constant, which is labeled result. And it is assigned the value input number times 2, which is 20. And then we are returning that result. So again, we are passing that variable back into where it was called previously. And now that local context is eligible for garbage collection. We're going to pop it off our call stack. And we're going to weave our toe back into the global execution context.
Terrible, terrible arrow that I've built.
I'm also going really fast, but
no. You're doing great. You're doing great. Excellent. Now what happens?
All right. So is this a trick question?
Of course it is.
We were back in the main code body, so now technically we're I hate to say we're done, but like we're done with this.
Yeah.
I guess. Okay, cool.
Our program stops. Our program stops running. Yes, 100%.
Okay.
Excellent, excellent job, Alex. Everyone give Alex snaps, claps. Yes, expertly done. Awesome technical communication. So some things that I want to draw attention to, right? I'm just going to go back a slide because my terrible handwriting makes this unbearable. Alex mentioned that, and rightly so, that this part of our function has a very specific name. Does anyone remember what Alex said? That is the function what? Shirley, I see your hand up.
Definition.
100% correct. This is the function definition. And the difference between this function definition and what's happening in these bottom two lines is that in these bottom two lines, the function is getting invoked. And the way that our thread of execution, the way that our interpolator knows that the function is being invoked is because it is being passed an argument, or maybe not, if it wasn't being passed an argument, it is seeing these parentheses come after the function label. Does that make sense to everybody? That's super important. Okay, cool. It will come up again, I promise. Awesome job, Alex. Thank you, thank you, thank you. You're crushing it. Keep it up. Yes. All right. Another thing to think about as we start moving towards closure and understanding closure more deeply. Functions. Oh, we got a question. Cam, go ahead.
Yeah, quick question. So I know when we talked about like when we spin up a local execution context, the engine is, I think we used like looking for variables. I have a question about that part. So how does that, I guess, activity work? What does that mean technically? And also is that looking for variables activity, is that distinct from like when we just start our code, we're in the global context and we're like initializing our variables in the global memory? Are those different activities? Does that make sense?
I think so. Can I play back your question to make sure I'm understanding correctly?
Yeah.
You want to know the difference between initializing a variable and actually calling on that variable, like where when do we look for it in global memory versus when do we actually create it?
I think so. Keep going, and that it might make
Okay.
sense to me.
Okay, cool. So the only time that JavaScript will ever check for a variable is if a variable is called on. So in our code, like Alex mentioned, JavaScript sees this keyword let and goes, okay, we're making a new label. So here's this new label, and here's the value that we're assigning to that label. Great. This is basically the same thing. Here's a new label, and here's the value that we're assigning to that label, this function definition. We come down here. Okay, great. Here's this new label, and the value that we're assigning to it is the evaluated result of this function being invoked, passing in this thing num. When JavaScript sees num, it goes, I don't know what that is. Let me check the global memory and see if that means something, if I should know what that means. It will see that earlier we said num is 3. It will take that value and invoke the function using that value as its argument. Does that answer your question?
All clear. Thanks.
Of course, for sure. Great question. Okay, cool. So we've talked about global execution context, the global variable environment, the local memory, the thread of execution, the call stack, all these principles of JavaScript that help us talk through code and what's actually happening under the hood. Now let's talk about some more like little finicky concepts that we can play with as developers. Functions can have multiple names. What do you mean, Sam? We just talked about this. There are 2 parts to a function declaration, right? There are 2 parts, the label, i.e., what are we calling this function, and the definition. What's happening behind the scenes in JavaScript is that this function, the label is really holding on to a reference or a pointer, you may hear it called. The label is holding on to a pointer that points to this function definition. So we can call this function and store the evaluated result in a variable, but we can also take the reference to the definition and store it in a variable. What is the difference between what's happening on this line and this line in the code? Can someone tell me? Hint, we already talked about it. As far as code goes, like what is the difference between these 2 lines? Adrian.
Well, on the output line, you're invoking it because of the parentheses as well as the number being passed in.
100% correct.
Yeah.
And what are we doing on the new label for multiply by 2 line?
We are declaring a variable using the const keyword, labeling it new label for multiply by 2, and setting it to the function definition of multiply by 2.
Expertly done. Yes, the function definition, 100%. So let's look at this in code. Anyone want to talk through some stuff? Will, I see you clapping. Does that mean you want to go? Yeah, excellent. Totally cool. Go ahead, unmute. Let's talk through it. We know that in order to have a global execution context, we need a place where we can store stuff. That is called what?
We need the call stack.
Yes, we do need the call stack for sure.
Is that what we're talking about?
Well, where would we store stuff? Like if we want to declare a new variable.
Oh, in the global memory.
100% correct. Global memory.
I don't think I'm going to get all of this right, by the way. I just wanted to walk through it in case, like, if I have questions, I could just ask you.
No, I love if everyone knew all this stuff already, why are you here? No, this is great.
So
Please.
true.
Yeah. Okay, great. So we have a call stack. That call stack allows us to keep track of where the what is.
The thread of execution.
100% correct. Keeping our toe in line. Yes. And as Alex reminded us, the bottommost frame on that call stack is always the global execution context. That's where we are. Great. Will, talk me through this code line by line. What is the first thing that JavaScript is going to do?
So the first thing we're going to do is create a new function, which is going to be called multiply by 2.
Mhm.
And that is going to take in a input number.
100%. So what is JavaScript going to do with that information?
It is going to, it's going to, well, like where is it going to go in the, it's going to put that into the global memory, right?
100% correct. So we're
Okay.
we're setting up a new label, right?
Hmm.
Multiply by 2. And stored in that label is going to be what?
Our function definition.
100% correct. Yes. Our function definition. Where is the next line that JavaScript's thread of execution? Where are we going to go next?
I want to say, so we go to the constant output variable.
100% correct. Remember, we're not invoking this function yet. So JavaScript, JavaScript isn't this rude, but it doesn't really care. It doesn't care what the function is asking us to do because we're not using it right now. We're just taking all that code that is the definition and storing it in this label for later. So you're absolutely right. We're jumping to line 5. Talk me through what's happening.
We're declaring a new constant variable called output, and output is going to be equal to multiply by 2 when invoking the input number 9. So that the result of multiply by 2 in taking 9.
Awesome stuff. Where is output going to live?
In the global memory.
Great. So we're setting up a new label called output, and you're absolutely right. It will be set equal to my favorite way of saying this, and it's kind of like a little flex, so forgive me, but take this, use it yourselves. The evaluated result of multiply by 2, passing in the number 9. Awesome job. Okay, so we hit line 5. We know that we have this new label output in our global memory, and it needs to be equal to the evaluated result of multiply by 2, passing in the number 9. JavaScript goes, oh, wait, okay, I need to use multiply by 2 now. What happens next?
So it's going to jump back to the function definition of multiply by 2. And it's going to find our constant result, or it's going to declare our constant result in the function definition, and which is going to be equal to our input number multiplied by 2.
Yes, 100% correct. Before we actually begin carrying out, executing the function, JavaScript needs to know itself that we're leaving the global space, right? We're going into a new space. So what happens before we even start any of that?
So we're going to move the thread of execution to the local memory, right?
To the local execution context.
Local execution context, that's what.
100%, yes. Keep going.
And then I guess in the local execution memory, it's going to take the constant result.
You're
right?
100% correct. There's just one more step that happens before that. So remember, how do we keep track of the toe? How do we keep track of where we are?
The call stack.
So we need to tell the call stack that we're no longer in the global execution context, right? How do we do that?
I guess the thread of execution would move from the or it would like I don't know what the word is. It would move it from the global call stack to the local execution context.
You're 100% correct. There's this funky thing that happens where JavaScript does what's called, it pushes a call frame onto the call stack. So it's essentially saying, oh, wait, we need to execute this function. So JavaScript, before it does any of this work, goes, okay, to keep track of where I am, I'm going to add this thing on the call stack called a frame. And by adding it, I mean push. Push equals add. I'm going to push this call frame onto the stack. And under the hood, it's usually represented by the name of the function itself. So now JavaScript knows, okay, my thread of execution is in whatever's on the top of the call stack.
I see.
Our thread of execution is now inside of multiply by 2, passing in the number 9. So now we've arrived, and now we can keep going.
Okay, so it's pushing a new, I don't know what the thing is. It's pushing multiply by 2 into the global call stack, but the thread of execution is moving to the local execution within multiply by 2. Is that what's happening, sort of?
You're 99% there, just one little correction. We're not
Hmm.
pushing multiply by 2 into the global call stack. We're pushing multiply by 2 onto the call stack, and we're exiting the global execution context. We're going into a local execution context.
Okay,
Yeah. Does
gotcha.
that make sense, kind of?
Yeah, that makes sense.
Okay. So now we're in this local execution context where we're actually going to carry out the invocation of the function.
Mhm.
So we passed in the number 9. The
Yes.
first thing that our function is going to do is what? Talk to me.
It's going to go into the function definition
Uh-huh.
in the local execution,
Uh-huh.
and then it's going to, in the local memory, I think it's going to declare the constant variable result, which will be equal to the input number that we're taking in with times 2, which would be 9 times 2.
Yes, 100% correct. Before we declare result, though, this is a
Mhm.
little finicky thing that happens in function definitions.
Okay.
This input number parameter, it's called a parameter on line 1, is a placeholder. Our function needs to know what that input number is going to be as it executes.
Okay.
So the first thing that happens in our local memory is we decide, or the computer program decides, what input number is. In this case, input number, the argument for input number was passed in on line 5. What is that input number?
9.
100% correct. So before we even start executing our function, JavaScript goes, oh, wait, we need something, input number, that's 9. Okay, now on to line 2. Repeat what you said because it was spot on.
I said it's going to declare the constant result,
Yep.
which is going to be equal to 9 times 2.
Which is?
The input number.
Yeah,
Right.
what is
which
9?
is was it equal to 18?
Thank you.
Okay.
You're good. Okay, cool. So
I'm gonna pull out a calculator for that one.
Totally fine. So we've got the result being equal to 9 times 2, and then what happens on line 3?
It's going to return our result to like out of our function into, I guess I'm kind of getting ahead of myself, I guess.
No, you're not. Keep going.
Okay, it's going to return our result, which will be 18, out of the function into our constant output. And it's going to store that variable back into the global memory.
100% correct. Expertly communicated. Now that the function is ended, there are 3 things that happen. What happens?
It's going to erase the local memory. And the thread of execution is going to move back into the global call stack, and it's going to, I don't know what the word is, it's going to like remove the multiply by 2 frame from the global call stack. I don't know if I got the order of all that right, or if I think some of that was right. I don't know.
Yeah, 100%. The order is a little bit inconsequential because it all kind of happens almost at the same time.
Okay.
Pops the call frame off the call stack.
Mhm.
Pop is the word.
Pop.
Expertly done.
Push
The
and
thread of-
pop.
Correct. The thread of execution exits the local execution context and returns to the global execution context. Yes. And you mentioned local memory being deleted.
Mhm.
A little adjustment to the technical communication. The local execution context, including the local memory, is eligible for what's called garbage collection. JavaScript says, oh, we're done with this junk. Leave it here in the corner until the program's done running and we can throw it all out.
Okay.
But awesome. Will, amazing job. Everyone snaps for Will. Yes.
I do have a slight, not even a question, but more of like a more like explanation of like what the local like what's really the difference. Like there's a difference between local execution and the local memory, but like is the local execution context just like when, like that would be like when the function would be invoked, and then the local memory would be like all of the things being declared within the definition, and then like the final thing that happens that like returns it out of the function, that's the end of the local execution context. Is that sort of how it works?
Yes, 100%. And you're getting into what closure is all about. And it's spoiler alert, there's going to be more discussion about this. But what you're asking about, Will, is, oh God, can't write, scope. So the thing about local memory is everything that local execution context has exclusive access to. So if we wanted to, outside in the global memory, outside in the global execution context, if the last line was like, or the next line, excuse me, was console log result, what would happen?
Nothing.
Exactly. We would get undefined because result doesn't exist in our global memory. It only exists locally to this function's execution context. Does that make sense? Okay. Awesome question. Excellent, excellent job, Will. Do you want to finish up with the last two lines, or would you like me to pass it to someone else?
You can pass it to someone else if you want.
Okay.
I think and I understand what the next two lines do.
Okay, you crushed it though. Expertly done. Awesome, awesome stuff. Who wants to take it up from here? Who wants to take the handoff from Will and talk through these last two lines? What's happening? Go ahead, Shirley.
So on line 6, we're going to declare a constant new label for multiply by 2 equal to multiply by 2, the function definition of multiply by 2. So we're just gonna rename the function multiply by 2.
Amazing. Where are we declaring this constant? Where is it being stored?
Global memory.
Yes, new label for multiply. Sorry for my handwriting. Okay. And we're storing in it what? Remind me?
We are storing in it with the constant new label for multiply by 2, and we're storing the function definition multiply by 2. Sorry.
Correct. No, you're fine. So you're absolutely right. We're storing in it the function definition again, because, say it with me, everybody, there are no parentheses after this label. We are not invoking the function. We are storing the definition. Awesome job, Shirley. Talk me through line 7. What's happening?
And then we're going to declare in global memory the constant fresh output, and it's going to invoke a new label for multiply by 2 with the argument 10.
Great. So what happens when we invoke that function?
It's going to open up a new local execution context, and that new label for multiply by 2 is actually going to be pushed onto the call stack, and then toe is actually moving into the local execution context.
Yes. New label, forgive my handwriting. And our toe moves in to our new execution context. Okay, great. Talk me through what's happening in this new execution context.
Okay, so the new label is basically the same as multiply by 2. So the input number, our argument is going to be 10. So that goes into local memory, and then we're going to go through the whole function. Constant result equals the input number by times 2. So it's going to be 10 times 2 is going to be the result. And then the return, it's going to return result as 20. And then after that return result, it's going to pop because fresh output is the evaluated result of new label for multiply by 2 with the argument 10. So it's going to pop back out into the global execution context, and fresh output will equal to 20. And then it's in the call stack, that function is going to be popped off. Toe is going to move back into the global execution context, and the local execution context is up for trash disposal.
100% correct. Expertly done, Shirley. Yes. Some things, little adjustments. Garbage collection is what it's called.
Okay.
When the local execution context is ready to go. And you mentioned that the result of 20 will be popped out into the global execution context. use the word return, just because pop is an exclusive
Mhm.
action
Okay.
for a data structure like a call stack. But yes, 100%. So what happened? What happened here? We were talking about naming the same function two different things, right? When we reassigned the function definition of multiply by 2 to this new label multiply by 2, what happened? The function still worked, right? It still did what it needed to do. We could store that definition, that reference to that definition in a new label, and nothing changed. Notice too that these results are independent of each other. So when we called multiply by 2 a second time on this line 7, it didn't have anything to do with this execution of multiply by 2. The two execution contexts are completely separate. Okay? Will, question, hit me.
So I guess my question is, if you were to just make a constant fresh output just be equal to multiply by 2 taking in 10, that would that just it would take in what the previous one was, like the previous result, and then multiply that by 10, or what? Because like that wouldn't be a fresh, because the function's already been called before, right?
But it would open up a new execution context. It would do basically the same thing that we're doing here, but just showing you that you can rename a function by passing it into a new label.
Okay, I guess I was just wondering what, like the function of what we're doing right now.
Yeah, I'll show you in a little bit.
Okay.
This is basically to let you know that if you rename a function, it will still work.
Okay.
So when we get to closure, you'll need to rename some functions in order to achieve closure. And under the hood, this is what's happening when you rename a function.
Okay.
Cool. I appreciate it. Okay. Here we are. We've talked about how JavaScript kind of works with these principles. We've talked about relabeling a function or having it exist under two different names. Now we're going to talk about the actual thing of closure. Before we do, please feel free to take 2 minutes, grab some water, use the restroom. We're about halfway through. We got another hour and 20 minutes to go. I will be back on camera at 41 past the hour. It is 39 past the hour right now. I'll be back at 41. Grab a drink, use the restroom. Join me in 2 minutes. 2 minutes. All right. I'm back. Start making your way back if you can hear me. Give you all another 30 seconds. Excellent, excellent, excellent. How am I doing so far? Am I talking too much? Thumbs? I'm talking too much. Thanks, Shirley. Thanks, Ryan. Thanks, AJ. Thanks. It was a trap. The question was a trap. There's no way.
Yeah, timing is everything.
Yeah. Okay, awesome. I know some people may still be away, but I'm going to talk really slow and get back into it. Okay, so we've talked about the difference between a function label, a function definition, invoking a function versus storing its definition in a new label. Now let's talk about what closure is. When our function gets called to, I think it was Cam's point earlier, when our function gets called and it's finished, it's garbage collected. The local memory from that function is garbage collected. It's scooped away, it's taken away, and we don't have access to it anymore. What if we could? What if we could build functions that memorize things? And when we called them subsequent times, they had access to their previous calls, right? We could build programs that were incredibly responsive. We could build, favorites. Like anytime you interact with any program that allows you to save favorites or remembers your history, chances are it's memoized. It's using some form of an encapsulated variable environment or closure. The closure gives our programs so much power. But in order to achieve it in JavaScript, the first thing we need to understand is that a function can return a function. If you're anything like me, my mind was blown when I first heard that. We can build a function, and inside of that outer function, we can define another function. Shirley, you're unmuted.
Sorry.
It's all good. It's all good. And that outer function can return that newly defined function. But remember, if we're returning a function like this, we're not returning the evaluated result of that function. We're not invoking that function. We're returning the function definition. Let's talk through this. Who wants to help us? Alexandra, go ahead. Talk me through.
Okay.
Yes, yes, yes. So let me get you set up here. We have the call stack. We have the global memory. We have our global stack frame on the bottom of the stack. And we need a toe. Everyone needs a toe. Great. Talk me through what JavaScript is going to do. What's that first line?
Okay, so in the global memory, we are going to declare a function with the label create function.
Mm-hmm.
And the value of that will just be the function definition.
Mm-hmm.
We will also declare a constant variable with the label generated func equal to undefined.
More specifically, equal to
the evaluated result of create function.
Amazing. So once JavaScript hits line 6, initializes that variable in global memory, and then sees that it's the evaluated result of a function, what's going to happen?
I'm sorry, can you ask that question again?
Of course. So once JavaScript hits line 6 and initializes this label in global memory, and then sees that it is equal to the evaluated result of invoking this function, what happens next?
Does that create a local execution context for create function?
100% it does.
Okay.
Does that make sense? Why?
Yes.
Because before JavaScript can store what it needs to in this variable, we need to figure out what is being returned by this function.
And that's because there are parentheses there, correct?
100% correct. Expertly done. Okay, great. So we've opened up this local execution context. Before we dive into the function itself, there are a couple other things that need to happen for JavaScript to keep track of what's going on. Do you remember what those are?
So we need to pop on the create function frame onto the call stack, and we need to weave our thread of execution from the global execution context into the local execution context.
100%. Do we want to pop on or do we want to?
We need to push the frame onto the call stack.
100% correct. Yes. Okay, great. So we've moved our thread of execution into this local execution context. We've pushed a call frame onto the call stack. Now tell me what's happening.
So we don't have any parameters to declare in the local memory, but within the local execution context, we have to push another local execution context. I don't know if it's the same phrase. It's another local execution context.
Yeah. No, I know.
And
this is a trick. I'm tricking you now. Talk to me about, so are we actually invoking a function on line 2?
We are initializing the function. Okay, so in the local memory, we're initializing the function labeled multiply by 2.
Yes. And setting it equal to?
And setting it equal to the function definition.
100% correct. Yep. Then what happens?
Okay, and then from there, the thread of execution weaves into a new local execution context.
Does it?
Am I jumping the gun here?
Tell me why you think that is.
Well, does num get declared in this local memory or in the next local memory?
So let's talk through like where we're at, right? So we are technically in the code, we're here, right? We've entered the execution context for this create function. So now we're weaving our way through here. All that's happening here, just like you said, is in our local memory, we're storing the function definition in this new label multiply by 2. So inside of this function, which remember is what we're invoking right here, we have now accounted for all of this information.
Got it. Okay.
So where are we now?
So now we are in the local execution context and returning the function definition of multiply by 2 into the global memory.
Into what label?
Into the create function result, or into generated function label.
Yes, 100%.
Okay.
So let me change my color back. Sorry. Yes, yes, yes. Awesome job. Yes. So we are returning, right, this function definition, just like you said, the function definition of multiply by 2 into generated func. So what is stored in generated func right now?
The function definition of multiply by 2.
Yep, 100% correct. So now that we've returned out of this function, we're exiting this local execution context. There are 3 things that happen. What are they?
Now we need to pop off the create function frame from the call stack.
Yep.
The local execution context is eligible for garbage collection.
Yep.
And then we find ourselves again in we weave the thread of execution back into the global execution context.
Awesome. 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 Awesome job. Yes. 100% correct, Alexander. Okay. So we just wrapped up line 6. What happens next?
Now in the global memory, we declare a new constant with the label result, and we set that equal to the evaluated result of generated func.
Awesome. Passing in what as an argument?
Passing in the number 3 as an argument.
Fantastic. What is currently stored in the label generated func?
So the label generated func is currently storing the value of the function multiplied by 2. So would we just write that result is the evaluated result of multiply by 2 passing in the parameter 3?
Yeah, but so specifically generated func is a function definition, right? That's what's stored there. And on line 7, because we're passing in 3, we have these parentheses wrapped around our argument. So we
the
know
invocation of
so
generated.
what happens when we invoke a function?
So we need to open a new local execution context. We need to push a new frame onto the call stack for generated func.
Yep.
And we need to weave the thread of execution back into the local execution context.
Yes, we do. Okay. So now talk me through what's happening.
Okay, so here we are now, we have to, okay, I'm searching for the words. Okay. So we have to initialize num to equal 3 in the local memory. And then in the local execution context, we are returning the evaluated result of 3 times 2, or returning 6 from the local execution context to result in the global memory. And by doing so, the local execution context is eligible for garbage collection. We can pop off the generated function off of the call stack, and we weave the thread of execution from the local execution context back out to the global execution context.
Yes, 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 yes. Awesome. Awesome stuff. Yes. Great work. Fantastic. So what you've just seen is a function, right? A create function, outer function, define multiply by 2 inside of itself, and return the function definition. So even though this local execution context is closed, right? And we're not calling create function again, we have stored this data that should only exist in a local execution context. We've stored it under a new label, and we're able to call on it later. Does everyone see that? Does everyone understand that? Any questions on this idea of a function returning a function? Will, go ahead, bud.
So I just have a quick question. If we made a argument for generate function, like if that parameter held something, like if we made generate function holding the parameter num, and then we did const generated func equals create function in taking num, and then const result equals generated func 3, like the number would be 3. Would it then, like, would generate function pass in the number 3, which would pass into multiply by 2 being 3, like would it return the same result?
So if I'm
like, is this only working because generate function is taking in an empty parameter?
No. So if we pass, you're saying if we passed in an argument. So like if our create function took, let's say our create function took num, and then outside of this function definition, we also wanted to like console log num. Is that what you're saying? Like, we could pass in an argument here. Yes, that is what you're talking about, is a closure. You're basically building JavaScript 3 slides too early, which I commend you on. But yeah, we can absolutely pass in a variable into this outer function. And I'll show you in a little bit how that would work. But yes, your
Okay.
mind is absolutely in the right place.
Okay.
Yeah. Not to get into spoiler territory, but I promise we'll talk about it, Will. Cam,
Okay.
what's up?
All right, so when we, for example, initialize function multiply by 2, and so when we initialize the function label in the definition in local memory, or where are the parameters stored? Is that also like, is that attached to the definition we're storing in memory? Is it somehow something with scoping? How does that work?
It is 100% attached to the definition. So you can think of the JavaScript interpreter as seeing this keyword function and saying, okay, whatever next chunk of characters follows this is the label. And then anything inside of these parentheses are parameters that need to be stored with the definition. And anything in between curly braces is the actual definition of the function. That is what's happening under the hood. So those parentheses coupled with the keyword function is JavaScript's way of keeping those parameters tied to the function definition. Yes.
Okay, thank you.
Great question. AJ, what's up?
Yeah, so kind of, I guess it's kind of like a larger question. So I don't know, you might answer this later in the workshop, but so I understand obviously we're creating a label which stores the value of an invoked function. You know, our last line is generated func3. If this was generated func2, it would be 4, correct?
Yep.
So I think where I kind of start not really getting confused, but I start kind of like asking questions is like, are we kind of getting close to like dry territory? Like I don't know, like, because when I hit a closure problem where like I want to store data, I start thinking of like objects. So I just don't know when to use this, and in my opinion, everything's an object, so why not just go to object? But I don't really know like when to go for closure versus objects.
Yeah. No, that's a solid question. And the answer is not very sexy is the wrong word, but like it's a lot simpler than or it sounds a lot simpler than it actually is. But the answer, AJ, is persistence. Like if we have an object declared in a function, right? Where is it declared? Is it declared globally or locally?
If it's declared in the function, it's locally.
Correct. So after that function is done running, what happens to that object? What happens to that data?
Yeah, we're out where garbage collected.
Correct.
Got it.
So closure is all about building things where we can have memory closely tied to functionality. And I'll show you in the actual closure example towards the end of this slide deck, where you could put an object inside of this closure concept, and that object persists. So like each subsequent call of this inner function could have access to that object, which is really powerful.
Cool. Awesome. Thank you.
Yeah, of course. But to your previous concern too about dryness, yeah, it may not look the most dry, but this concept of returning a function and storing it somewhere else is the only way to achieve closure.
Gotcha. Cool.
Solid. Okay. Awesome work, you all. Oh, Hannah, yes, talk to me.
This is a bit of a silly question. So like, I know what the function definition is. So generated func is the function label, right? Is that like the name for it? Is there like a fancy name or anything?
I call it the function label. Some people will call it, a variable. Some people will call it a constant because it's declared with a const keyword. As long as you understand that this is essentially a placeholder in global memory for the evaluated result of create func, you'll be okay. That's all this is a placeholder.
All right, thank you.
which doesn't really answer your question. It just adds another word to the long list of things that we could call it. So I'm sorry, but I've only ever heard them called labels. So that's what I use.
All right, thank you.
Yeah, for sure. Okay. So this idea of a function, an outer function defining a new function in its definition and then returning that function definition is paramount to Clojure. Something that we could also do, right, is we could define that function inside of an outer function and then actually call that newly defined function inside the local execution context of our outer function. Let's see what happens if we do this. Who wants to talk me through it? Having so much fun. You all are killing it. Someone throw up a hand. Come on. Cam, go ahead, bud.
All right. So from the top, we already kind of labeled our things. We can draw a little line for the toe if we want.
Yeah, that's a good idea. Give me 1 second. It's going to give you some line numbers.
Oh, love numbers. Thank you.
Sorry, 6. That will be 7. That's we'll call 9. Okay, so you said toe. Yes. Let's get a line going. Awesome.
Love it. Sorry.
You're good. Go ahead and start us out. What's happening in this first line?
Okay, so we've shown global in the call stack. So on the first line, we are going to be declaring a function label outer and global memory, which its value is just its function definition, so the F box.
Excellent.
And the next thing we do is skip all the way down to 9, where we will be firing, invoking the outer function.
Yes.
All right, so our thread of execution is going to take us into a new execution context that's going to, I can do this. It's going to push a new frame onto our call stack.
Yes. I'm making this big for a reason. I'm sorry.
All good.
So we'll call this new frame outer. Okay, what happens next?
So now that we are entering our local execution context, we're going to initialize any variables, no parameters, but we do next have on line 2 the variable counter that we will establish with the label counter assigned to the value 0.
Before we go too much further, I'm sorry to interrupt you. I hate to be a stickler. There's one more thing that happens before we actually enter the local execution context. JavaScript needs to know where it is. Where do we move our toe?
Oh, sorry. We take the toe into the local execution context of outer.
You're good. I'm such a stickler for it. Okay, you're absolutely right. There are no parameters, nothing, no arguments need to be stored in local memory. So we're on line 2. Talk me through it.
We're on line 2. We are initializing the variable counter, the label counter assigned to the value 0.
Where?
In local memory of outer's execution context. Okay. Next on line 3, we will then declare the function label increment counter in the local memory of this execution context, which has its own function definition with the F box.
Yep.
After that, the code will be invoking increment. Oh, it's invoking, not returning. It'll be invoking increment counter.
Yeah, what does that mean?
What does that mean? So it's going to spin up another execution context for us. So we're going to add another frame onto our call stack for increment counter.
Yes, yes, yes.
Our stickler, our toe, is going to dip into the waters of increment counter as well. All right. And similarly, we're going to establish our memory variables. So checking nothing new is established in this scope. So nothing happens on that front. The execution thread then goes to line 4, where we will increment the variable counter, which is in the outer memory of this, up by 1.
Yes. So let's talk about what's actually happening on this line, because this is a little finicky and this is where Clojure starts to happen. Counter, right? We see this keyword counter on line 4. Where is the first place that JavaScript is going to check for this word counter?
I believe it checks the local context of this function increment counter first.
You're 100% correct. So it'll look here and it won't see it. Where will it check next?
It'll then step one, I guess, layer out. So it'll be the local memory of the parent function outer. Or maybe I didn't use the word parent there, but you know what I mean.
I think parent is totally valid. And what will it find something called counter there?
It finds the variable counter that we instantiated a while ago.
And what is stored in that label counter?
Right now, the number 0.
Correct. So if we pass the number 0 down one level into this local execution context of increment counter, counter plus plus, our increment operator, will turn that 0 into
hopefully a 1.
If everything goes according
to everything goes right.
Yeah. Great. And then a bit of a trick question, what happens next?
So the function is completed, we're stepping out, we're popping it off the call stack, thread of execution, or I'll slow down.
No, you're good.
Thread of execution weaves back into that outer local execution context of outer. And we've also flagged that increment counter function is eligible for garbage day, garbage collection. And now we are back in the execution context here. We're going to do the same thing. We're now ready to step out of outer, so it's going to get popped off our stack. Execution context goes back, or the thread goes back to the global execution context, and outer also gets flagged as eligible for garbage collection.
And our program stops.
And it stops.
Awesome. Yes, 100% correct. Nothing's being returned. Nothing's being console logged. Awesome, awesome job, Cam. Yes, 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 yes. So the lesson here is when we invoke a function inside of an outer function where it is defined, this local execution context has access to all the memory inside of itself and, as Cam so aptly named, inside of its parent function and inside of the global namespace. So even though counter doesn't exist inside of this function, we have access to it. Jesus, I look like a psychotic person drawing like this. Even though increment counter doesn't have an argument counter, it doesn't have a variable defined inside of it of counter, it has access to the execution context outside of itself. Because this variable and this function definition exist inside of the same local execution context. Any questions? We're getting to the meat and potatoes now. Alexandra, go ahead.
Did you mention that it also has access to the global memory?
It does, yes. So if we had on line, let's say 0.5, right? If we said const counter is equal to 10, we would have counter here equal to 10. The way the hierarchy goes of things is JavaScript will always check, like Cam said, execution contexts in order of ascension, hence the call stack being important. It will check execution contexts going down the call stack. If we had counter as 10 in the global, our result would still be the same. However, if we removed line 2 and had counter as 10, our new result would be 11. 100% correct. AJ, what's up?
I'm pretty sure I understand the functionality of, I guess, access to the parent memories. But I just want to confirm kind of the logic. It's not, it's only unidirectional. It's not bidirectional. I guess if there's other I guess, nested functions, they can't go in, like one nested function can't go into the memory of another one. It only goes up. It only trickles, I guess, trickles up.
Yeah, correct. Yeah, if we had another function defined here with another variable, it wouldn't, yeah, that's, my brain hurts thinking about it. Yes. So if we had multiple calls and they existed in execution contexts next to each other, but they share the same parent, yes, memory here is not shared. It is individual.
Right. Okay, cool. Thank you.
That's correct. Great question. Someone else had their hand up. Will, what's up?
So if we were to invoke outer again, or yeah, if we were to invoke it again, would it then increase the counter to 2?
What do you think?
I think yes, but also I think no at the same time, because like the local memory gets garbage disposal, what's the word?
Garbage collected.
What is the word? It's some things to garbage collection.
It's eligible for garbage.
It's eligible. That's one, because it's eligible for garbage collection, right? So like it gets effectively like not erased, but like it would get erased. So if you were to invoke it again, wouldn't it just do a new instance of it?
Yes, you're absolutely correct.
Okay, so it wouldn't like compound.
Correct. If we invoked it again, this counter would be reinitialized as 0 in a new execution context.
Okay.
But what you're driving at again, Will, you're killing it, is closure. There is a way to write this so that that number persists in memory, and we'll talk about it. Alexander, go ahead.
I'm sorry if you already talked about this. My brain is just a little slower with some of this. Could you call increment counter outside of that function?
What do you think?
I want to say yes, but because it's defined in that local memory, would you have to call outer first?
So if
before calling it.
Yeah, if this increment counter function, if the definition only exists in this local memory, do you think we have access to it outside in global?
No.
Correct. Do you see why?
Yes, I think I'm just trying to figure out what the point of having a function. I guess if you always have to call outer and then you have to call increment counter inside, wouldn't there be a way to just do that without having to write 2 separate functions?
Yes, but you wouldn't be able to achieve what we're setting out to achieve, and I'll show you why.
Okay.
Keep that in mind. I promise it will hopefully be clearer. I promise it will hopefully be clearer. Woo, what a promise. Kat, hi there.
Hi. In regards to like business architecture, do businesses typically want to keep going inwards into local execution contexts because of like the independence of those functions that you can create from the I guess like the parent global like execution context?
I'm not sure I understand your question. Can you ask it again?
Yeah, so like I guess for the functionality of having like local execution context and like basically like going within them, if you want to put another function within them, in businesses, would they prefer for like any functionality like updates or anything like that? Is it preferred to keep doing that, going inwards into local execution contexts for independence from closure?
It depends on the logic that you're trying to achieve. If we're trying to achieve some kind of functionality that it rests on a lot of other functionality, and we don't want that inner functionality to succeed without the previous steps, then of course it makes sense to scope it this way. But if we have individual services that are trying to be carried out independently of each other, then absolutely nested functions like this and closures like this are probably excess and unnecessary. It just kind of goes with what you're trying to achieve. It's a good question.
Gotcha. Thank you.
Yeah, for sure. Okay. Alexandra, is that an old hand or a new hand? You're good. Okay, cool. Okay. We've talked about relabeling functions. We've talked about returning function definitions from functions. And now we've talked about calling functions inside of other functions where they're also defined. I'm very excited because we've arrived. This is closure. We can call a function outside of the function call in which it was defined by returning its definition into a new label. So all these steps that we've talked about are all coming to a head. And I know you may not know what to do or what to expect, but I urge someone who hasn't spoken yet tonight to try to communicate us through this. Would anyone like to take a stab at it? I'm right here. I'm going to help you do it. Lane, let's do it. So let me set you up with some line numbers so that I don't make this unbearably impossible. Give me 1 second. 1, 2, 3, 4, 5, 6, 7. We'll call this 9, 10, 11. Okay, Lane, whenever
now it's going to bother me that you didn't put an 8 in there. So 8 in there.
There's an empty line in there. It's an implied 8.
That's line 8.
All right, I'll put an 8. Okay. Lane
It's
is
weird.
and I appreciate it. Okay, whenever you're ready.
All right. So we're going to start in the global memory over here, in which we have a function definition outer.
So we're storing that function definition in the label of outer in the global memory. I love it. Yes.
And then we are forgetting about everything else and just going down to line 9.
Yes.
Which is a constant variable, my new function.
And where are we storing that?
That is being stored in the global memory.
Yes. And what's being stored there?
The evaluated result of calling the function outer.
Talk to me. What happens when we hit that evaluated result call?
As soon as we get to there, now we are going to open our new local execution context.
Absolutely.
We are going to push that onto the call stack.
Expert.
And the thread of execution also weaves into there.
I forgot about the toe. Thank you. Yes. Okay. I'm with you.
Right. Now we are going to go inside of that code block for outer, in which we have a variable called counter, which is assigned the value of 0, and that's stored in the local memory.
Excellent. Yes. Counter is 0. Okay.
Next, we have another function definition called increment counter. So in the local memory, that's just stored as the function definition.
Great. Increment counter, and there's a function definition. Okay.
Then the next thing we have is to return increment counter.
Great. So what are we returning?
I'm going to guess we're returning the whatever the evaluated result of increment counter is. Wait.
Yeah.
There's no parentheses there, so we're returning the function.
The function what?
Increment counter.
But specifically the function what of increment counter?
Oh, the function definition of increment counter.
So we are returning the function definition of increment counter, and we're putting it where?
We are returning that to the global memory.
Under what label? Tell me.
Under the my new function label.
100% correct. So now inside of my new func is the function definition of increment counter. Talk to me what happens next.
Yep. All right. So then we're moving on to line 10, which is in which we invoke my new function.
I hate to be a stickler.
Or,
I hate to be a stickler. We've
oh,
finished.
we gotta garbage collect all the things.
Yeah. Talk through 3 steps, always 3 steps. What are they? You said
Yeah, we're gonna garbage collect our local execution context and local memory. We're going to pop that off of the call stack, and then the thread of execution goes back into our global execution context.
Thank you so much for putting up with my haranguing. Line 10 when you're ready.
Okay, now we are going to line 10, in which we are invoking my new function.
Mhm.
So since we're invoking my new function, we are going to open up a new local execution context and local memory, push that onto the call stack, and weave the thread of execution into this new little area down here.
Yes.
So since my new function is assigned the function definition of increment counter, that is what we're going with. So we're just incrementing counter by 1.
Yes. And what is counter?
Counter was 0, so now it is 1.
Okay. So we'll say counter plus plus means counter is 1. Where is counter right now?
Well, counter is in the other local memory.
Huh. Okay. I'll say right now, you're right. Counter is 1. Let's keep going and think about that while we keep moving. Okay.
Yeah, I can't remember where it's supposed to go, but it exists out there somewhere.
It's all good. Yeah. So tell me, now that we've ended this function, right? Because we've hit line 4 inside of increment counter. What happens to this local execution context?
Now this one gets garbage collected and is popped off the call stack.
Yep.
And our thread of execution goes back to the global execution context.
Absolutely. And then we hit line 11.
Line 11 is we are invoking my new function again.
Yeah.
So we're going to need our new local memory, the local execution context, which will also be pushed on top of the call stack.
Sorry, I'm trying to arrange things, make it a little more legible.
Yeah, all good.
I'm with you.
Yep, thread of execution goes down to this new call for my function. And then we go into our function code block and we increment counter by 1. But somehow the counter is already 1, so now it's going to be 2.
Yeah. I just did counter hashtag. I don't know why. Okay. Counter, you're saying is 2.
Yep.
Why?
Just as JavaScript knows, there's probably some better reason for that, but just
Totally fair. Okay, let's finish the program and then we'll talk about it. So we've now made counter 2. What happens next?
Now that is done, we are going to garbage collect that local execution context and local memory, pop it off the call stack, and I don't see where counter is going.
That's okay. Third thing that happens after we finish a function execution.
Thread of execution goes back to the global execution context.
Yeah. And then our program ends, right?
Yep.
Where the hell is counter going? Let's talk about it. So when did we first see counter? Where is counter initialized? That's the word.
Oh, so is counter now going into our function for outer? So it's initialized in that local memory for the first time that we went through outer.
No, that's not where counter is being stored currently, but It is where counter is initialized. You're right.
Oh, you know
So
what? There's some weird word for this, right? That I learned in CS prep. Is this the closed over variable environment?
Yes, it is. Yes. But so counter is initialized in this local memory of the outer function, right? But then
Yep.
outer function is garbage collected. So when does this, when is this moved somewhere else where it could persist? And the answer is this line. Line 9. When, I'm going to go back to this just because it's cleaner and my handwriting is atrocious. When we assign a function definition, because that's what's happening here, right? When we assign a function definition to a new label, anything that exists in the local execution context where that function definition is established, anything that exists in that local execution context comes piggybacked onto that function definition. So when we assign on line 9 the evaluated result of outer into the my new function label, outer returns a function definition. That returned function definition has on its back the variable counter. And when we invoke my new function on line 10 and 11, what function are we actually invoking? Can anybody tell us? Because remember, my new function is a new label for a different function. Alex G.
We're actually invoking increment counter.
100% correct. We are invoking increment counter. So Lane is absolutely right. On line 10, increment counter, counter becomes 1. Specifically, the counter that exists in the backpack of my new function. And when we invoke it again on line 11, counter becomes 2 because counter persists. AJ.
I think this kind of answers my confusion with OOP and closure. Because I think we start talking about protos and prototypes, and I'm like, okay, it has access. But I mean, if we're creating another instance of the function, then I think that definitely makes a bit more sense. Because I was like, okay, well, it has access. But this definitely helped out, man. I appreciate it.
Of course, you are 100% right. Nail right on the head. This is what allows for us to build classes and for us to have individual instances of classes that aren't affecting each other. You're 100% correct. Alexandra, what's up?
I think that AJ might have just asked that. I was going to ask if other objects, other properties, other code is in function outer, all of that comes along and can be manipulated with each invocation of my new function. If that was to be what it was manipulating.
Yes, that's correct. Okay. That addendum is very important. Yeah. If increment counter didn't do anything to counter, it wouldn't need it, right? It wouldn't do anything about it. Nothing would change on the program. Yes, 100%.
Got it. Thank you.
Yep. Blaine, what's up?
Okay, so then just curious, what happens if, forget this my new function. So what happens if we just call outer again?
That's a really good question. What happens?
I feel that there is a chance that counter is still 0.
hold on to that question. I have something on the next slide that will help you. That's a great question. Will.
Okay, so maybe I'm getting a little bit ahead of myself here, but let's say hypothetically, so the function outer stores inside of it another function, increment counter. What if there was like another function inside of increment counter called, I don't know, who cares what it's called? When my new function is equal to outer, would it then be still like technically be equal to like the evaluated result of increment counter, or would it be equal to the evaluated result of the function inside of increment counter?
Great question. So really what's happening here on line 9, right, is we're storing the evaluated result of outer. So even if we had another function inside of increment counter and we had another function inside of that function, the thing that's being stored here is whatever's returned by outer. In this case, it will always be the function definition of increment counter.
The evaluated result of outer.
Correct.
Okay, that's where I kind of get confused.
Yeah. So again, the evaluated result, we know that's what it is because we have these parentheses. We're invoking the function. The evaluated result of outer is the function definition of increment counter.
Gotcha. That makes way more sense. That was when I was first trying to, like, before I watched this, when I was first trying to get or before I was in this thing right now, I was trying to get a hold of it. That was like so confusing to me. I was like, we're calling outer, but we're actually calling increment counter. Like, what is that?
Yep.
That makes a lot more sense.
No, great call out. Just to reiterate, spot on. The evaluated result of outer is the definition of increment counter, and we're only ever calling increment counter when we put those parentheses on the end of these my new function calls. Great call out. Okay. This is closure, y'all. We just saw it. We just saw it happen. These 2 lines proved that our data can persist. So if we're writing this program as a team and we have these 10 lines in our code, and then Will comes in and crushes it one day and writes 10,000 lines after this, and then I say, oh crap, I need to call my new function one more time. At the end of those 10,000 lines on line 10,001, if I call my new function again, the result will be 3. Our data will persist no matter how much noise happens in between. Okay. This is what we're talking about. This bond that happens underneath the hood. When we store a function definition in a new label, and when that function definition comes from an outer function where variables are also defined, those variables come along bonded to the function definition. This bond is called a backpack. That's what we call it. It is a way for our functions to hold on to information. All this information on this slide we've already talked through, excuse me. So I'm going to skip this slide for now, but again, you will get these slides. This is a revamp of everything that we just talked through. This backpack has special names. I think Lane mentioned one earlier. I think Lane said closed over variable environment. The super flex, super Saiyan name for this is the persistent lexical scope referenced data, which you will never hear anyone with a soul say, but you can absolutely flex and say it in your next icebreaker question. The informal term is called a backpack. The slightly more formal term is a closure. Closure didn't really make sense to me until in my brain, I changed the word closure from closure to enclosure. We're enclosing these variables alongside the function definition. They are one. If you see this in practice in an actual computer program running in the browser, you can open up the properties of a function definition, and you'll see these closures happen in something called the bracket scope. It is the scope of that function. And in that scope are these environment variables that persist. That's closure, y'all. But someone had a question earlier, I think it was Lane. What happens if we call outer again? Here we go. Here we're doing it. We call outer once, and we know counter here is 1, counter here is 2. We just talked through that code. What happens if we call outer again? Does anyone want to wager a guess what these two will give us? Alex.
Because we're invoking outer as a function again, we're basically passing the scoped variable or the backpack to the new label again. So we're basically starting over, and we're starting the cycle over essentially. So now another function as a label, once again, is equal to the function definition increment counter, excuse me, but with counter now set back to 0. Apologize, everyone. Yeah. So the answer, another function, when you invoke that, the next 2 times should be 1 and 2 again, because of the closure variable, how it resets itself.
Spot on. Excellent technical communication, Alex. Yes, you're 100% correct. Because we are reinitializing counter in this invocation of outer, we are setting up a new backpack, a new closed over variable environment, a new closure in this another function. If after these 2 another function calls, we called my new function again, what would my new function be this 3rd time? I see your fingers up, Ryan. I'm calling on you because you're absolutely right. It would be 3. And it would have nothing to do with these being 1 and 2. We could call it again, it would be 4. Then we could call another function again, and it would be 3. These are independent closures, even though they're coming from the same function definition. That is what happens if we call outer again. This is closure, y'all. Why? Why do we do this? Why is this important? It gives our functions memory, and those memories persist. So I used this example earlier on, but it is my favorite real world example. Anytime you're playing a video game and you've done something and the game needs to remember that you did it, I bet 9 times out of 10, that game is running the same function over and over again, but it's checking a variable in this closed over variable environment. And if that variable is marked as true, then you've already done it. And it probably returns out of that function. And you don't get to have that dialogue chat with that NPC because you've already done it. It is a way for our programs to remember when they've been run last, what the evaluated result of their last run was. That's a memo-wise pattern. It's very, very, very popular. It allows us to build iterators, generators. It allows us to use the module pattern, i.e., I'm building this program and I want to export it to this other program. Well, all those variables in that program that your program needs to run inside of that new parent go along with it. It also allows for us to run asynchronous JavaScript. If you don't know what that is, it's all good. If you don't know what anything that anyone has said tonight is, you're right where you need to be. It is okay. Every developer started by console logging hello world. Never forget that. Okay. That's it for tonight, y'all. What's next? Keep coming. Come back more. Yes, I will have time for questions. I promise. I'm not just going to duck out. But keep coming to more of these things. I'm going to start doing more of these. I would love to see you all again. Please come hang out. Hop into pair programming sessions. There are community pair programming sessions. Please do those. They are amazing. Utilize CSX. It is a free resource. It is awesome. And yes, I have fast track codes for you. Here they are. Again, no need to write anything down if you don't want to. You can absolutely screen grab right now if you prefer, but you'll also be sent these slides. These fast track application codes will get your foot into the door of the software engineering immersive, if that's what you'd like to do. You just need to be sure to apply by the end of the day tomorrow. Okay. I am here. I'm happy to answer any more questions you may have. I'm happy to talk about anything you'd like to talk about, the program, closure, what I'm watching on TV, which is nothing. But if you need to go, it has been an absolute pleasure seeing you, having you here. Thank you for your energy and attention. And if you want to hang out and ask some questions, I'm here. Cam, what's up, bud?
All right, I've got a few questions. They get increasingly complex. First one is a function that we've created with a closure attached to it. Is that an example of I think it's a pure function is the term I saw in other materials. So it's like, it's not like, since that variable is local to it, it's not interfering with anything else. Is that an appropriate use of that term?
That's a really great question. I'm not 100% sure. I think it would depend on a few factors. I would argue that a closure is not a pure function, just because I know a pure function is specifically not creating any side effects. And there are a lot of side effects that come with closure. I don't know 100% though. I think it would depend on what kind of functionality you're building into that closure.
Okay, that makes sense to me. Next is the backpack the closure? Is that like distinctly part of the local memory of the new function, or is it like adjacent or attached and linked via the scope property? Or is it something totally different?
I think it's both. I think what you're saying, I think both the things you're saying are correct. So like when we return this definition of increment counter, I'll call it IC.
Yeah.
On that definition here, right, is a little backpack in the form of the scope variable, right? The scope property, excuse me. So that exists local to this function and also in global memory because it's stored in this global variable.
Sure, but it's still fair for me to say like it also exists in, like, it's part of the local memory of increment counter.
I think it would be safer to say that it's a property local.
It's a property of, okay. Thanks for clarifying that. And
on
then
the definition of increment counter, yeah.
A property on the definition for increment counter. Okay, that's clear. Then I have one more. This one's a little more tricky, so I hope I get it right on the first try. So when you have closures for multiple functions that were created in the same execution context, so if we were returning more than just increment counter within outer, CSX, when I was reading it, it said that they will access the same variables in memory. But I thought that the variables lived like in the backpack of these individual functions. So is there like some sort of, how is that being linked? Like how is, if counter was still just counter and we had multiple functions inside outer, how do they all hold on to counter and treat it as the same thing? Does that make sense, that question?
I think so. Let me play it back to you. You tell me. So you're saying if we have a counter here, and then let's say we have another function in here, and we'll call it decrement, right? Decrement counter. So conditionally, okay, we return either increment counter or decrement, depending on whatever, right?
Sure.
Both of these function definitions will have access to the environment variable of counter when their definition is returned out of this parent function. However, it will not be the same counter. So if you and I pass, if we run this function twice, if we run outer twice, and we return increment counter one time and decrement counter the next, each of their backpacks contain an independent counter initialized at 0. And if we call increment, let's say my new function stores increment and another function stores decrement, this will result in 1, this will result in 2. If we're decrementing by 1, decrement will result in -1, -2. These two counters are separate of each other, even though they're coming from the same function. Does that make sense?
That makes sense.
If they were the same, like this is not what's happening, but if they were the same, this first decrement call would be 1, right? Because 2 minus 1 is 1, but they're not the same, they're individual.
Okay. And sorry to keep pushing on this topic, but how would we create a situation where decrement and increment refer to the same backpackized thing? Or is that like, how would that happen, what you just showed me?
Yeah, so this is where, I don't know if AJ is still here, if they left, but this is where something like using an object would come into place. Like if we had an object stored in this counter variable, like if we said const counter is equal to an object where we have like a true count and a false count, right? Or we could just have counter in there. Then I would, as a developer, say, instead of calling this increment counter, I would call this like effect counter or something. And then depending on whatever was passed into this call, we could know that we either need to increment or decrement it.
Got it. Okay, that's all clear. Thanks for entertaining my tangent.
Of course, yeah, just like a little bit of abstraction allows us to have that power to do two different things.
Cool, all clear. Thanks, man.
Yeah, for sure. Alex, what's up?
I have a quick question just about ES6 syntax. I know CSX kind of reinforces it a lot. Where does that stand in industry best practices? Because I honestly find it more confusing, but I've tried to make the habit of writing my inner functions with it, and like my function parameters with it, but like, is it used in the industry?
Yeah, it is. Pretty.
It is, okay.
Unfortunately, pretty extensively. I will say I am 100% in the same boat as you. When I first saw this weird thing, like I was like, what the hell am I looking at? Right? Like what do you mean arrow function? Where are the parameters? Where's the return statement? Like there's no return. What is happening?
And then you'd write const label equals if you were to name it, right? But
Right,
like
yeah.
I know how that like seems it's supposed to be easier, but honestly I find it almost more confusing in a way.
Yes.
Yeah.
It will become second nature the more you see it and the more you interact with it. And I know that's terrible to hear because it hurts to say. Trust that it will. And it is really very, very popular in the industry. And it gets even crazier. And I don't know why. One of my colleagues, he says this all the time and I love it. He's like, we're paid to write code. Why would you want to write less code? Like you're paid to write it. Why wouldn't you want to write it? So there are a lot of people who are the school of thought, write it clearly so that when you write an awesome function, Alex, and I come in the next day and have to review your work or use your work to build what I'm building, it should be really clear. There are some people who aren't in that school of thought, and a lot of those people, unfortunately, are in leadership positions at companies around the world, and they just want things like really efficient and as few lines of code as possible. And
it's like newer.
It's also newer. There are no performance gains. Like it has no effect on the performance of your algos or your functions. It is literally cosmetic. But I promise you, the more you look at it, the more you think about it, the more you start to use it, it will become much, much easier. I was in the exact same boat as you. I mean it genuinely. I didn't write an arrow function until like 3 months into the immersive program.
And now that Internet Explorer is gone, you have to use it more probably. Yeah. All right.
Yeah. Internet Explorer is deprecated as a whole, but yes, especially with like functional front end frameworks like React now utilizing hooks and that becoming the industry standard. Like even front-end engineers are writing front-end code in ES6 arrow functions. So it's I hate to say it, you're not going to escape it, but it will
So
definitely
start now, definitely.
Well, also just like don't feel like in a rush to understand all of it, because there's a lot and there's a lot of adjusting that it takes, but don't shy away from it. And if you feel empowered to start writing them, start writing them.
Like, should I get into the habit of writing the main function body as that, or is it still best to start the main function as a keyword function and then, or does that not even matter?
Personal preference. Again, they're exactly the same under the hood. So whatever makes you feel the most comfortable. Like if writing the outer body function is enough of a challenge, like just do that. But as you get more comfortable with like native array methods and you want to start writing reduce callbacks as arrow functions and it looks friggin' crazy, it looks like some kind of weird, sometimes impossible to understand stuff, go for it. But until then, write it when you can, read a lot of it when you can, and just know that it will take effect. It's like, if you go into a job interview tomorrow and you don't use arrow functions, you're not going to not get the job because of that. Like you're not. You can write vanilla function definitions and you're fine. It's just something to get used to because a lot of developers use it and you're going to be reading a lot of code as a developer.
Methods are the only ones that I only know how to do them with the arrow function. So
there you go.
But anyway, that's all.
Solid. Yes. Alexandra, what's up?
All right, I'm a little self-conscious because I feel like this is a very basic question, but I am a little bit confused by the fact that outer is returning the function definition each time. So when you're calling the function, to me, or when you're calling outer, to me, it would return the same thing every single time. Yes. So where does counter actually increment from if you're not returning like the evaluated results of the function? Like it, to me, it would just be returning the definition, returning the definition, returning the definition.
Yes.
Why does it change?
The short answer is because we're redefining the function every time. This is why defining the function inside of a function is paramount. Because, sorry, I'm switching slides so much. So because we're defining increment counter inside of outer every time, just like this variable, right? If we got rid of this function, if we got rid of all this stuff, and we called outer here, and then we called outer again, those two variables would be independent of each other, right? We wouldn't have access to those cross execution contexts. So with the same concept in mind, we are storing the definition of this function inside of a variable in the local execution context of outer each time it's called. So this definition exists only in this execution context until it's returned. And then if we call outer again, we're redefining, like it's a new definition. It is uncoupled from this definition. Even though the code looks the same, remember it's a reference to the function. The reference is different.
I think I'm gonna have to sit with that one for a little bit.
Sorry, is there anything that I can do to help clarify?
No, I think I just need to look at it. Thank you. I appreciate it.
Of course. Yeah. It's a tough, this is where closure comes, like this is it. This is the hurdle. Meredith, what's up?
Hey, so I don't have a question about closure, but I do have a question about pair programming, if that's all right. I feel like I'm getting ready to start pair programming soon, and I'm curious, when you're new to that, do people like work through CSX together, or are there other challenges you use? Like, what are the materials for pair programming?
It's a great question. CSX is a great source of material. So yes, 100%. And I think there is a CSX Slack channel that you can join if you're not already a member. there are always messages, hey, I'm around, can anyone pair for a couple hours? And you dive into program challenges, CSX. Yes. There is also, a repository of a bunch of pair programming questions and algorithms that are made available to you when you come to one of those Codesmith community pair programming sessions.
Gotcha.
Come to those sessions because those questions are then yours in perpetuity, and you can use those anytime you want to pair program. Yeah.
Okay, cool. Thanks.
Great question. Anyone else? Erica, what's up?
Hi, I have a quick question about if it's possible using to access, I guess, the value of counter with the variable label my new function, or if you would need to return the value of counter within the definition of increment counter, if that makes sense.
Yeah, we would have to make some changes to the code. It's possible. Right now, as this code is written, not so much. But yes, if we returned or console log counter inside of the increment counter definition, then we would have access to it here. Yes.
Okay, great. Thank you.
Yeah, great call out. Will, what's up?
Okay, so I have a question that's unrelated to what we're talking about directly in here, but it has to do with closure.
Yeah.
It's a concept that's addressed in one of the CSX problems. Am I allowed to like share my screen? Is that okay?
Well, also, if you'd like, tell me what question it is, because I can pull it up and I can share my screen.
It'll be challenge after in closure and scope. So my question is, so we're creating a constant, which is going to be called, and that is equal to a function that takes in a string and returns hello plus that string. And we're creating another constant called after called, which is equal to the function that we created taking in 3 and the function called. So when we log it in console.log with with world, and it eventually prints out world or hello world because of how it runs, whatever. We call after called, and then we put as an argument inside of after called the string world. After called is equal to after. So is it basically just, it already knows, like we already know what is going into after, so we add world and that just like transfers down into our function cycler argument?
So this is a great question. Specifically world, this argument is taking the place of this parameter.
That's what I thought, but I'm just kind of wondering, like, if there was another function inside of cycler, could we put world comma another argument, and then it would be like, okay, that one's going to go down to the next one?
Yeah, you can. I mean, the way that makes sense. We can.
But if you wrote that differently, if you just wrote like instead of like ... args, just wrote like string or whatever.
Yeah, we can actually do it right now because I've written. Let me see. I think this should work. Nope, it doesn't. What am I doing? 3 after callback. Oh, because the callback is only expecting one string.
Yeah.
Okay.
But if you were to write like another one, if you were to change ... args to just like one argument, and then make another function inside of it, and make it one argument, and you made, you did world comma hi, I don't know. Yeah. Would it then like, it would take in world for the argument for cycler, and then it would take in hi as the argument for the function inside of cycler? Is that kind of how it works?
Yeah, so I think to achieve what you're saying, we would need to change the parameters like I just did in the callback function, which is this called function, right? This is the callback. So I've written cycler this way to account for multiple arguments being passed into the new label. That's what's happening here, right? This is the new label. If we pass in more than one argument into this new label, our inner function is accounting for those. The callback is not. So by adding this, it's called a rest parameter. If you don't know what that is, I highly recommend you look it up. It's super powerful. This rest parameter allows for multiple arguments being passed to this callback function. thus giving us this result. Like we can put in 600, like I can copy and paste this all day. Well, I'm going to need commas. But if I do this, it doesn't matter how many arguments I have, it will work.
It'll just keep adding them on.
Correct.
I see. So then how would you, if there was another function inside of cycler that took in another parameter, how would you then, in the console log after called, how would you then give that, like, how would you then input that parameter?
Sure. Well, it depends, right? If we have a function definition inside of cycler, and let's call it cycle2, and it takes a number argument, right? And it does, let's say console.log that number. That's all it does. If we ever call this function, right? Like if we call on the next line, if we say cycle2, we can pass in whatever we want as the num. And it can be like you're saying, if we add number as the second argument there, that's in our scope. And we can invoke cycle2 passing in that number from cycler. And then we would have to specify that the second argument that we pass in here is a number.
Okay.
And then every argument after it can be whatever we want.
I see.
Does that make sense?
It does. But what doesn't make sense, I guess, is because the first argument in cycler is an argument that takes in multiple arguments.
Yeah.
Why would the 3 not be counted as one of those arguments that's being taken in?
You're 100% correct. It would actually need to be the last one.
But even then, why would it not count as one of the many? Because it's a different, because it's not a string, it's an integer or a number.
Yeah, it has nothing to do with type, ironically, it has to do with placement in our argument list. So because in the function definition of cycler, we've said, hey, we're going to have a whole bunch of arguments, or maybe one. They're going to be strings, maybe, I don't know what they are, but all of these arguments rest these together, rest these parameters together. And then the last one, specifically the last one, I'm going to refer to as number in this function. So like that specific one, pull out and hold, remember, in local memory as number. This is why the order of your arguments matters, right? Like so let's say I got rid of this rest parameter and I put name, date, arg, and number. If I wanted to invoke this function using the arguments Sam, today, no, and 10, if I passed in 10 and no, even though 10 is a number, JavaScript goes, oh, 10 is arg right now, because that's the order that these arguments are passed in. Has nothing to do with the actual name of the argument. It has to do with their location in the definition.
Yeah, it does make sense, but I'm still confused. Like it makes sense in this way, but with the resting argument, I forgot what you call it. I still don't understand why it, like how it differentiates. Is it because it's the last one in the order? It knows this one is going to be different than that other group. Like it's just because it's the last one. So if you were to take it out, or if you were to take it out and make Sam the last one, it would say number, it would be Sam.
Correct.
Okay, that makes sense. I thought it was just like an infinite thing. It's like, oh yeah, it's going to take in all of these arguments. As
I got you.
If you place it at the end, it'll count as the next argument in the order.
If you're not familiar with it, what the rest parameter is actually doing is it's taking all the arguments and putting them into an array. So it's taking this indefinite amount of arguments and arrayifying them. And by specifying that we want the last argument to be a number, JavaScript will basically go, okay, everything in this argument list needs to be moved into an array. Oh, except for the last thing. So let's index in 1 and hold on to that last thing.
I got it. And then it would take that last thing, it would put it into, or I guess you would change it to num in cycler, and it would take that, and then we would call it in our function cycle2, and then it would take that number and put it.
Correct.
Would you even need to put a parameter in cycle2 since we already have called it in this in like the parent function before it? If you were to remove that and just do console.log.num or console.log.num, would it still just?
So we wouldn't be able to do num because num isn't defined.
Number. Yeah, we would do number.
But yeah.
And that would print our 3 still, right?
That's literally a closure. Yeah.
Okay. Okay, cool.
Would it be bad practice? Would it even work if you were to do 2 REST parameters next to each other? Like, how would it know when to differentiate?
That's a really good question. I suspect that it wouldn't.
Okay. I figured if nothing else, it was probably bad practice because it seems like it would be confusing, but yeah.
Yeah. I also can't really think of an edge case, like a use case for that. Like,
okay.
Just because of single use principle, like you want a function to do one thing. And if you're taking in multiple lists of data, like they should already be in an array or a list like form. Like,
sure.
Yeah,
sure.
that hurts my brain.
yeah. I was just curious.
No, that's great.
I guess slight other question. Would you ever see like backpacks within backpacks using closure, or is that just not something that generally happens?
Yeah, of course. I mean, yeah, you can absolutely do that. Again, use case, but like I've seen modules which are in themselves closures contain functions that also have closures. Like, yeah, for sure.
Okay, cool. I was just curious. Thanks.
Great question. Y'all, it's been a pleasure. Thank you all so much for hanging out with me. Thank you for the amazing engagement, awesome questions. I hope to see you all applying and taking technical interviews. Can't wait to see you all. Have a good night, everybody.